Hello friends, in our today's class we will be seeing the elements and order of elements in this Z modulo MZ cross Z modulo MZ and Z modulo M square, that is M into M is Z. These two are same or not. We are going to see that. That is, if I take M to be 2, I will do for Z modulo 2Z cross Z modulo 2Z and Z modulo 2 into 2Z, that is Z modulo 4Z. I am going to take these two groups and I am going to check whether these elements and order of these elements are same or not. First of all, I will take with Z modulo 2Z cross Z modulo 2Z. Z modulo 2Z cross Z modulo 2Z. I have already explained how to find the elements of this group. And I have given that link in the description box. You can refer to it. It consists of zeros and ones. I mean Cartesian product of zeros and ones. So it is 0, 0, 0, 1. 1, 0 and 1, 1. First we will find the order of each and every element, and we will find the order of each and every element in Z modulo 4Z. We will compare that too. First of all, before that we will find what are the elements of Z modulo 4Z. It consists of elements from 0 to 4 minus 1. That is 0, 1, 2 and 3. So these two are not the same. So elements are not the same. Now we will compare the order of these elements. I will find the order of 0, 0 in the Z modulo 2Z cross Z modulo 2Z. The order of this is LCM of order of 0 in Z modulo 2Z and order of 0 in Z modulo 2Z. So how to find the order of 0 is 0 into A equal to 0 mod 2. That is, I am going to multiply 0 with A, that is inverse of order of 0 in such a way that I'm going to divide that product with 2 and I should get the remainder 0. So I can take 1, 2, whatever I want, but I'll take the least one, A to be 1. So LCM of is equal to LCM of 1, 1, which is 1. So order of this 0, 0 is 1. Similarly, we will find for 0, 1. It is LCM of order of 0 in Z modulo, this is the first one, 2Z, and order of 1 in Z modulo 2Z. We have already found we have already seen what is the order of 0 in Z modulo 2Z, which is 1. So it is LCM of 1, 1 into A equal to 0 mod 2. So I'll take this as some other variable B. It's your wish. You can take whatever you want. So I take B as the order of 1, which is 2. Because 1 into 2 is 2. I divide 2 by 2. I get the remainder 0. So it is LCM of 1, 2, which is 2. So the order of 0, 1 is 2. Similarly, if you find the order of 1, 0, you will get the same answer. LCM of order of 1, order of 0 order of 1 is in z modulo 2z, which is 2. So LCM of 2 comma order of 0 in z modulo 2z is again 1. So it is 2. If we are going to find 1 comma 1. So it is the LCM of order of 1 and order of 1. These both 1 are in z modulo 2z. So instead of finding these two orders, and finding the LCM of it, I'll find just only the one thing. Keep it in mind. If I'm going to find LCM of two same elements in same group, that is order of A and order of A, same in z modulo pz, then I don't have to find the LCM of it. Just finding the order of A is enough of it. So order of 1 in z modulo 2z is 2. Again 2. Now we will find the order of elements in z modulo 4z. First I will find the order of 0 in z modulo 4z, which is 0 into A equal to 0 mod 4 here. Because 4 is there, so 4 here. 2 is here, 2 is here, so I wrote 2 here. 2 here, okay. So A here is 1. Similarly, we'll find for 1, 2 and 3. So 1 into, I'll take this as B is equal to 0 mod 4. Similarly, 2 into, I'll take this as C equal to 0 mod 4. In this we are going to find A. We have already found A. So B, C and D. This is 0 mod 4. So here B is equal to 1 into 1 is not, if I divide 1 into 1 by 4, I don't get the remainder 0. 2, I don't get the remainder 0. 3, 4. Yes, 1 into 4 is 4. 4 by 4 gives the remainder 0. So B is 4. 2 into 2 is 4. Divided by 4, I get the remainder 0. So C is 2. 3 into 4 is 12. 12 divided by 4, I get the remainder 0. So D is equal to 3. If you compare these two orders, I got the first order of the element to be 1 and I got 1 to be 1. But there are 1, 2, 2. 3 2's here, 2, 2, 2. But there are, it is 4. There are 4 to 4 here. So the order is also not same.